Okay, so we're looking at a question. In 1992 presidential election, Alaska's 40 election districts averaged 1,969 votes per district for President Clinton. The standard deviation was 585, so that's my standard deviation, and then it averaged here, so we're talking about votes. There were only 40 election districts in Alaska, so that tells me this is all of them. The distribution of the votes per district for President Clinton was bell-shaped. That tells me it's normal, that it's bell-shaped. Let X be the number of votes for President Clinton for an election district. Round all answers except part E to 4 decimal places. So the first question is just asking us, what is the distribution of X? And it's normal, because it told us it was bell-shaped. And we know the average, that's 1969. And then our standard deviation goes in our second spot, or slot. Now, the other one wants to know, is this a population mean or sample mean? Well, since this is all the districts in Alaska, that tells me it would be the population mean. So it's the total. We didn't draw, or we didn't randomly select a group out of this 40 election districts. We took all of them to find this mean and this standard deviation. All right, part C says, find the probability that the randomly selected district had fewer than 1,825 votes for President Clinton. So we're looking for the probability that our random variable, which are the votes, for the number of votes for President Clinton, is, it said fewer than, so less than 1825. So that's what I'm looking for. So I'm going to use my calculator to figure this out. So I have my calculator, and I'm going to go to second vars, and this brings up several distributions. Remember, this one's a normal, so I have a normal CDF. Highlight it, enter. And this is the TI-83, so it's a little older. The newer calculators tell you that this is, you have a lower bound we're going to put in, upper bound, the mean, and the standard deviation. So under this normal CDF, we're going to put the lower, upper, the mean, and the standard deviation. So let's put this in. Well, it says we're looking for less than 1825. So I like putting in just a really small number. Could be 10,000, 100,000, 1 million, just as long as it's really small compared to what we're looking for. 1825 is our upper bound, because if you think about our normal distribution, and let me just draw a picture. Here's our normal distribution. Here's my mean. It's going to be in the middle. And our mean was 1969, which we're going to put that in there here in a minute. And so less than 1825, well, 1825 is going to be somewhere over here, and it's going to be anything less than it. Okay, so that's where my lower bound is a really small number, and then 1825 is my upper bound. So, comma. And then my mean, we found that was actually given to us. 1969, comma, 585, and then close the parenthesis and enter, and I get 0.4028. So round to 4 decimal places, and so my answer for this is going to be approximately 0.4028. So let's look at the next question. Find the probability that a randomly selected district had between 2,131 votes and 2,410 votes for President Clinton. So again, I'll draw a picture of our normal distribution. There's our mean. And remember, it's 1969. So we're looking at votes between 2131 and 2410. So they're going to fall above, going to be higher than my mean, somewhere like this, okay, where this will be 2131, and then this one will be 2410. So again, those are our boundaries we're going to put in to our normal CDF. So let me bring my calculator back. Okay, and again, second bars, normal CDF, enter. My lower bound for this one is 2131. My upper bound is 2410. The mean and the standard deviation is the same, 1969 and 585. 1969 and 585. And I come up with 0.1654, and that's rounded to 4 decimal places. 0.1654. All right, now let's look at our last question. It says, find the third quartile for votes for President Clinton. Round your answer to the nearest whole number. Okay, so if you remember our third quartile, that would be 75% of the votes. So again, draw a picture. Now remember my mean, that's going to be my 50th percentile. So my 75th percentile would be somewhere over here. And so that's telling me that 75% are here. So I want to find out, what is this value? We know our mean is 1969. So I want to know, what is this value here? That would be my 75th percentile. And it says round to the nearest whole number. So that's important that we round to the appropriate whole number. Okay, so this time I'm going to do an inverse normal. Let me bring my calculator back here. Alright, so I go to second bars, and you notice it says inverse norm. I'll go down to number 3, hit enter, and it brings up a parentheses for inverse norm. For our inverse norm, we would put in the area, the mean, and the standard deviation. So this is how we put in our inverse norm. Our area is the 75%, or the third quartile, which is the 75th percentile, which is 0.75. So that's what will go into the first comma, and then the mean, which is still 1969, and the standard deviation 585, and I get 2363, and we want to round that to the nearest whole number, so it would be 2364. 2364. So that tells us that 75% of the votes were less than 2364.